Okay, week 2. So this week in the lab, pay attention. This week in the lab, pay attention. Good, ready? So this week in the lab, we wired the primary control as a step 1. We will wire this at least 7 more times. That was the primary control. We wired, well, yesterday. We're gonna wire this week, this primary control, and that's gonna be week 1. Week 2, we'll combine this primary control with aquastat. Aquastat is used for hot water systems. The more wiring we do, the more experience we'll have, the more this will be like second nature to you. I promise if you pay attention and you follow up with the labs, by the end of the semester, this will be like second nature to you. Like putting a battery in a remote control. So, it should be the same. So this time, we're doing a single zone hydronic system. So single zone, how many thermostats do we have? One. We're gonna do single zone, 2 zones, and 3 zones. And this is 1 zone, but we could add another zone. And we'll see what options we have in adding these zones. So we'll do a single zone hydronic system. If you have the Weinberger book, this chapter 14. If you don't, it's okay. You don't need all the details. Whatever information I'll provide in this class. So limit controls. I'm gonna put this here. So this is called the primary control. It controls the function of the oil burners. Can you see without glare?
Yeah, that's better.
Huh? Oops. Put him present. You blew his cover, man. That's not cool. So anyways. If you look here, this is the cat tail. These are the neutrals for these components. So the igniter going to have, okay, you're going to connect this to the igniter, and the neutral from the igniter will come here. This will go to the motor, and the neutral will come here. Oil valve. For the limit, what did we do yesterday? We combined those together because it was only primary control without aquastat. And if we don't want to use those limits, we will just use 1 neutral going back all the way to the neutral coming from the plug. That's the primary. So now we will add this control. It looks messy, but it's not. Okay, so most of the time it's very labeled. This is line voltage. So what goes in here?
120.
Hot, neutral. Okay? Coming out of here, ZR and ZC we're not going to use this time. ZR and ZC go to the zone, second zone, if you have one. If you don't, then you don't need to connect that. Then, we should have a TT terminal, which is here. What goes in here?
Thermostat.
Thermostat. So remember the thermostat that went in here?
Yeah.
What are we going to do about the thermostat here?
Connected to the transformer?
No.
Wait, so you're saying there's a thermostat coming into that TT?
Yeah.
Oh, into that one?
Yeah.
So that would
We have only 1 zone.
So that go onto the TT of that, right?
No. In this
No,
case,
what?
we'll jumper this one, which means always on.
So we would find...
Because this control is controlling the little one through the limit. So this TT here will be jumpered in this case. Just put a small wire between them, and the thermostat will go in here.
TT straight to that.
No, in here we'll put a jumper wire. Means it's always on. And this TT will go to the thermostat. Okay? ZR and ZC, we're not going to use this time. FF, we're not going to use in here. We're still going to use the FF in here. Goes the cat cell. And we have B1 and B2 and B1 and C1, B2 and C2 and B2. So B1 will go to where?
The burner.
Which is
The
where?
control, right?
Yeah, it will go here. Which line? Marcus, here.
Burner is the.
It's gonna go into the limit.
Oh yeah, okay.
Because now we can use the limit. Once the limit gets activated, this thing is wired, ready to go. Once this get a signal from B1, boom, it will activate.
What happens if you jumpered the aquastat and you disconnected the primary controller to the thermostat?
I didn't follow. What do you mean?
If you jumpered the aquastat at TT
Yeah?
and you disconnected the primary controller directly to the thermostat.
That will defy the purpose because then, once the TT activates, this will turn on. It's not going to turn on.
It's not going to turn on?
Yeah, because the limit is not activated by the aquastat. The aquastat is not getting any signal, so you're gonna get nothing. Good question, because this is important on what to jump. So think about it as this is the little sub brain, and this is now is in control. They call this system integrated system. So the primary is controlled by the aquastat. Make sense? C1 goes to the circulator pump because we are using again hot water system, right?
Yeah.
So the circulator, once the temperature is within those two limits, it will kick in. That's why it has its own relay. What is C2 and B2?
It's just the common.
Thank you. It's the neutral. So usually 2 is the neutral. So it's not as complicated as it looks. It's mostly labeled. Once you do it once, twice, you'll be okay. And you start to develop the sense for it. Okay, C2 and B2. I have a burner. I have a thermostat. This is my input. This is my output, and so on. If it feels confusing, it's okay. These things I can talk about it until I'm blue in the face. But once you do it, okay, you get it. And it will be fun, promise. So limit control, operating control, primary control. Primary is this one. Aquastat is this one. Try to have good consistent terminology, but at the end, if you can make it work, that's what matters, you know. So primary control the monitor the operation of the oil burner. So the primary is responsible for the oil burner function. It will monitor the ignition, it will monitor the oil, it will monitor the flame. The aquastat has nothing to do with the burner. It just wants heat. You deal with it. It tells, okay, we don't have hot water, turn on the burner. That's what it does. It has a set shutdown, lockout. If it doesn't see the flame, we saw that yesterday. If it doesn't see the flame, then it's going to shut down, and there's a problem with the flame. We have to deal with it. And it's good to know who's at fault, the primary or the aquastat. Flame detection system, 2 methods, either with heat or CAD. With heat, it's not the code anymore. We talked about it in the last class. With heat, usually we use bimanual expands. It takes 90 seconds. It's not very common anymore. We use the CAD cell control. What is CAD cell control?
Senses light.
Yeah? It's cadmium is over there. If you look at it over there, it's called cadmium sulfide cell.
Oh yeah.
Once it's in the dark, it has very high resistance. Exposure to the light and photons will make it have lower resistance until it will connect. Questions? Concerns? This is the heat detecting system. You'll see it, it does exist, but it's not the code. But if it's there, you can replace it with exactly the same. But if you update the system or put new equipment, you cannot use that as your primary heat. Yeah.
one time had to play with my aquastat and I accidentally turned the limit. The limit was 180, and then I accidentally turned up the low limit.
Yeah.
So they matched. So it kept the boiler at 180, but the circulator wouldn't turn on.
Yeah. Good point.
Like-
Let's look at that. That's a really
Can you
good
go
thing.
back one page real quick? I can get the last one. Okay. Alright, I'm set. Thank
Wow.
you.
So something that can go wrong with the control. Those contacts here can get dirty. You can clean that with a spray. That's the contact. And make sure you have proper connection with those terminals. Make sure there's clear contact between the wires and the contact. Check the power. Do not mix the TT and the 120. This is how you burn the board.
Oh, it's starting? I don't know.
So make sure you don't mix the
Sorry.
boards. No problem. Check the low voltage circuit. Check out the jumpers. Check everything is clear, nothing is connected. Always before you finish the job, check the safety timing. How do we do that? We go and simulate failure. Take out the cat cell and cover it and see if it's gonna respond to problems. Want to go back a little bit quickly? Once you're done.
It's gonna be.
So this is some checks you want to have with aquastat. Louis, you can come later, but you can't keep talking. So you want to check those things. Make sure you have the right voltage. It does happen a lot where people put power in the put line voltage in the thermostat, and this is how you burn the board. It happens more than you think, especially if you're in a crowded place and it's really dim. Make sure you have the right terminals. And again, we are working with ideal situations here. In the lab, everything is clear and you have space and you can see everything. In real life, probably you did a boiler in real life. It's really in a very crowded, cramped space. You can't see the wire clearly. So make sure all the wires are the same color, like a bird's nest. So pay attention to that. I want to show you something here.
I can't read my handwriting.
Are you done? Who's not done?
I can't read that.
So in the lab yesterday, we did have you simulate a failure for 30 or 40 seconds. Good?
Do we cut this material on a blackboard?
It's in blackboard. Everything's in blackboard. So, we're checking the power. If the aquastat is not working, I want to check that the power coming into the aquastat is 120. How do I do that?
Using
You're going to
remote?
go with your multimeter, put in a voltage, and go check between those two pins and make sure that you're getting 120. Maybe you're getting 50. Maybe there's a short somewhere. It does happen.
Isn't there usually a light indicating that there's power to the board?
Yeah, that's in the new boards. What if we get one of those
Yeah,
relics?
just I was wondering.
So, and actually, I like working with these because these are easier to diagnose. The new ones have a lot of code and you have to hold and reset and all this kind of nonsense. I personally feel more comfortable with something I can see. The new ones, the hydrostat, are very complex. I mean, either it works or it doesn't. Maybe I have one here. I mean, look at that. What are you gonna do? Either it works or it doesn't.
Pretty much.
I can't check anything in it. Okay, so if it works, that's good. If it doesn't work,
The bad
$250
board.
down the drain.
Yeah.
Make sure you keep the receipt and get your refunded. We're good? So make sure you check the power here. Line voltage 120. We have a transformer, which means we have that's for the thermostat. The thermostat is powered by those two terminals. So what voltage should I be getting here? 24. Make sure it's 24. It's not 22. It's not 20. Other than that, you can check the terminals. Use a screwdriver, insulated one. Try to see if it's going to connect or not. If it's getting power. You can also check from the back. Look at the board. Make sure it's not burnt. All those lines, which means connections are clear. Sometimes they get loose. And usually, this is again very common, be very careful. When people put this in the board, the metallic casing for that, usually it has a board.
Bill's is telling that.
Yeah.
Oh, yes,
If you
yeah.
stick it too much, you're going to shorten the board. So make sure they're not touching. You know what I'm saying? See those pins there? In the casing, usually they leave a cardboard in the back, so this does not touch the metallic casing. Because if it touches, then this is connecting, and you're gonna have a short. And they're burn the board. And they're not going to give you a refund for that.
Right.
Again, $250 down the drain. So check that. What Tracy was talking about is those limits here. So the low limit. So this controls, yeah.
Oh, I'll let you finish. I just wanted to double check.
So all this control is doing is maintaining the water temperature between those two limits. The differential is number of degrees below the low limit, if you want some. So it doesn't kick. If you have smaller space, like Tracy said, like if you put this at 180 and you put this at 180, and you have differential at 0, which this one doesn't allow you, probably it's gonna be on the whole time and it's not gonna kick the circulator. You still think the water is not in the right temperature. So you want this around 120, this is around 180, differential between 10. So if the temperature falls out of below this limit, it's going to turn on the boiler. If you go for heat, the circulator will first check the water. If the water is cold, there is no point of circulating cold water, right? You're just wasting energy. So it's not going to do that. High limit, you don't want to go too high. Like 200 is reasonable. Above that, you might go into like steam. Which
Yeah,
you
why
don't
does
want.
it even allow you to do that?
Huh?
Why does it even like allow you to go over boiling point?
Well, it depends on the system. If the system is pressurized, you can
Oh.
go over 212. So it does work this way.
So my question, or just I'm double checking. The
Yeah.
only things going from the aquastat to the primary control are the wires coming from B1, B2, C2, C1,
Yeah.
and that's only going in.
Now, okay, the B1 will go to the primary.
Yeah.
That's it. And everything else goes from the primary to the burner
Oh,
controls.
because the B1, B2, C2, and the C1 that goes right to the circulator.
Yeah.
Okay.
So yeah, C1 and C2 go to the circulator. B1 and B2 go to the primary over there.
So really, that connection going to the limit is just a common wire between the two controls.
Exactly.
That controls the primary control.
Correct. Correct. Yeah.
So when we wire it with an aquastat, is the limit gonna be wired to the
That's good
aquastat?
to know.
Yes,
So
with B1.
One wire going from that aquastat to the burner.
I know the limit, I know the handheld control. Testing the CAD cell. So we did that yesterday, just to reiterate how did we test the CAD cell. Maybe I should just show you.
We're at 10th grade, let's do it.
assume the aquastat controls the primary control?
Now this is the primary. This is the aquastat.
Right, so does the aquastat control the primary?
Yes. That's called what? Integrated system. Non-integrated, everybody acts independently. But let's not get into too much into that. Okay, so first thing to test the cat cell is I use my multimeter, best friend here. You put it on resistance. Really?
It's time to get another one.
Ready. Those batteries last years.
Until you need to use them.
So you have a backup. Okay, so this is my cat cell receptacle. This is the cat cell. It looks like the stuff you see in your night light. You plug it in and you test for resistance. So first you want to test it in the dark. So you cover it up. What am I getting?
Numbers.
42,000.
Covered. Dark.
You see it?
That's kilowatts.
Yeah, that's kilo ohm. Okay? If it sees the light,
Gotta get down.
very low. And it changes with the amount of light, see? So it's sensing how much light is there based on the resistance. The higher the resistance, the darker the place, less light is there. So this is how you test it. You cover it, you should get something more than 10,000. Again, this range over time reduces. So eventually it will wear out and you have to change it because it's chemical based. There's a lot of photons. Eventually the chemicals will wear out over time. Okay, we did that already.
Did you get it down?
We talked about that. Basically, you want to check how much power is coming into it. And if you jump on the thermostat, it should run because it says that the primary is getting signal. So we jump on the terminal, measure the low voltage circuit. You can also, I'm gonna check you now. So you jump on the thermostat. If I call for heat and the cat cell is on, what do you think it will do? Like it sees the light outside. Will it turn on or not? Why would it turn on? The burner.
Why would it turn on the burner?
Yeah. If there is fire inside the chamber, it will not turn on. It will give you an error. So if you take it, if you want to test it, you put. Can you make more noise, please? So if it doesn't see the light, then you think there's no fire. Why are you calling for heat? Something is, doesn't make sense. What if I unplug the cat cell light?
Stop.
Yeah.
See any fire.
It means it's dark, right? There's no fire. So it's going to go in error. So we'll practice doing that a little bit. I know memorizing it doesn't help. When you experience with it a little bit, it makes more sense.
I'm missing the last one.
So there are different kind of relays. Some of them use UV, some of them use photo cells, but the most common ones are the primary control. Switch relay, that's something we'll do next class, not now. The switch relay will go into the zone, CR and ZC. That's when you have extra addition to your house. Let's say you have a built second floor, you have an annex, you put a new hot system to it, and you want to have 2 zones. So 2 zones, you're gonna need to add a switch relay. That's a photo of the primary. Again, they look, sometimes they have different configuration, but the idea is the same. There's always L1, L2. They are usually labeled T1, TT, which is thermostat, C1, C2, CRZC, and B1 and B2. It's very common. Even the new ones, the electronic ones, they still try to stick with the actual label. This is what it looks like right out of the box, and this is actually a brand new one. They still make them the old way. Again, it's an option whether you want to have the electronic or the mechanical. The price is very similar.
But which one is more convenient?
It depends. It all depends. So on the board, we did that. This week we have our safety switches. First time we just connected the primary. It was here. Oh, it fits. That's here. So we connect this by itself. This next week we'll add the primary to it with 1 thermostat. The week after we'll add the switching relay and 2 zones. Then we'll do 3 zones with the Takeo or Taco switching relay. This is the schematic I'm going to give you. Hopefully by now you don't need it, but if you get confused, you can refer to this simple schematic. Color coded: blue is ignition, purple oil valve, orange is motor, black is hot coming from B1 to the CAD, and you can connect all the components together. You can see how it gets involved once you have more components. You have a lot of wires together, like white wires, like okay, all over the place, big bundle of 6 wires together. That's not really convenient. You can use a strip. There's a strip in the board. If you see this strip over here, you can have one common going all around them and connect all the switches to it. The Rodriguez is being noisy. So again, just to see what did we observe out of this class, what are the 2 methods to detect heat or flame? Heat is one of them. What is the second one? Light. What is the best way to replace defective control?
Buy a new one.
Yeah, same exact model. It's who asked me whether should I replace it or not? If I really don't want to spend too much time, I'm gonna get the same exact model because it's already been wired this way. If you get a new model, you might have to do new wire. You're gonna have to change the configuration. It's better to have the same exact one and follow up with whatever was there. The CAD cell, what is the maximum allowable safety timing for residential systems?
15 seconds.
15 seconds. Last year it was 30. Now it's 15.
It used to be 45.
It's 45. That was 3 years ago. 3 years ago only. So when I took the test, it was 45 seconds. Now it's 15 seconds. What happens to the CAD cell resistance when it sees the light?
Goes down.
Goes down. What is the resistance in the dark?
You said like 10,000 plus.
Above 10,000. Yeah. Could be whatever, but above 10,000. Why? At 10,000 there will be no connection between those 2 resistances. If the CAD cell terminals are disconnected, will the burner start?
No, I'm guessing there's some kind of a safety function.
No, the burner will try to start and shut off.
I give 15 seconds. It will start for 15 seconds and shut off.
Yeah.
Because it doesn't see the flame. If the CAD cell terminals are jumping, will the burner start?
No.
No.
Still no light.
Because think there is light, think there is flame in there, it's kind of dangerous. So it's not going to start. What does a safety lockout do? Safety lockout is, it's called also a hard lockout. That's when you do a reset 3 times. It will just do a hard lockout where you have to go and press and hold for 1 minute. Or sometimes you have to press and hold, press 2 buttons together. Why is that? If it tries to make fire in 3 times and something failed, You gotta check the system. Don't keep hitting the reset button. When you go for a service call, I cannot emphasize this more. Probably the owner hit the reset at least 3 times. Goes into reset button. What are you gonna do? First thing you do when you go into the situation?
Hold the reset button.
No. You're gonna assume he did hit the reset 3 times. What are you gonna do?
Yeah, hold it. You said you had to hold it for a minute.
Yeah, but should you do it? Huh? What should you do with first thing when you go to a service call after trial for ignition happened and no fire? Well, first thing that the code tells you to do is go and check the chamber, because chances are the reset has been hit 3 times or maybe 6 times and the chamber is full of oil. So check that first, and if you do start it and fire doesn't start, it's going to be a lot of smoke, it's going to be a lot of back pressure. So if there's a small door, you can go with a mirror and check, or just take the burner out quickly and look inside the chamber. I know it's a little bit too much work, but it's worth it. It does happen. It did happen here in the shop once. One of the two was trying over and over again, and eventually when it lit up, it was on for like 3 hours because of the amount of oil inside it. Yeah, and a lot of smoke. So please check.
So, if there is oil inside, what you should do next?
Good question. You have to clean it. You have to soak it with rags, put it in a bag, put some
I can guarantee.
put some speedy dry or something. Try to soak as much as you can. If it's the kind of chamber that soaked all the oil, probably you have to change the casing. Otherwise, it's going to be burning continuously. But mostly, it's going to be a spray. You can go with put gloves on, get some rags, and dry it out.
What do you do with the speedy dry and oil?
Put it in a bag, and if you go to the warehouse, probably you have disposable chambers.
You mean go at the shop?
Yeah, whatever you bought, you buy the stuff and speedy dry.
Where you buy the speedy
Yeah.
dry is where
Like
you
a hardware store, usually they have disposable containers there.
they charge you?
I don't know.
Oh.
I think maybe it's paid in that.
So where you buy the speedy dry, not where you buy the oil?
Yeah. Or you can check online actually for like, if you're in the business, probably you know what to dispose of it.
Yeah, I don't know.
Yeah. Once you start, you'll find out. But I know that the warehouses have hazardous material container. In the shop, we have one of those. So leave it there. Because this is very contaminated. So again, yeah, this is something you have to check. What's an integrated system? The thermostat, pay attention, because this was in the oil burner example. What's an integrated system? Thermostat controls the operation of the burner and circulator. Non-integrated thermostat controls the circulator only. These are from the oil burner. Differential range of operation, it's the lower limit plus the differential. High limit control, the thermostat turns the burner off if the temperature is too high. Makes sense? Low limit, turn the burner on when the temperature is too low. Circulator control, turn on the circulator pump when the temperature is between those two limits. Good?
What did you say was oil burner questions?
The first 3 ones. They ask you what's integrated, what's not integrated. This is a black board, by the way.
Yeah.
Oh, yeah.
See, I tend not to go on my computer if I don't have to.
Good? So if there's a warning on the control or on the burner, take it seriously. It's not for show. So they wouldn't put something unless it's really important. So there's a warning here. I'll show you. It says fire hazard, of course, severe burn, prevent fire or spilling fuel. We should control only once. Call local service company if burner does not light. Electrical shock hazard. because this is also controlling the electrodes, the igniter. So take that serious, man. Don't plug the board without checking with me, please. I know we're working with boards, and when we work with a live actual burner, do not plug it before you check with me. And don't get too excited. Double check the board. It happened. A lot of people get excited. Last year, somebody got excited. The wire got loose, and he wanted to put it while the board was on. So it's funny until it happens to you. So be careful. It's not going to be a big deal. Hopefully it's not, but just be careful. Don't get too excited. And again, because you're working with 7 other students, so somebody is going to be next to you. He might be jolted, he might be startled. So pay attention to that. When we're trying to test the aqueous-static function and the bulb, you have to heat the bulb, right? Do not use torch or a lighter or direct fire. It's not designed for that. It will ruin the material inside. What do? The best thing to do is get hot water. So I have a burner there and hot water with a temperature, and it should function. Because if you look at the bulb here, it was designed to be completely submerged in water, not only one spot. If you use the torch, probably you're gonna heat one spot rather than the other. So some part will be boiling and the other is not boiling. Yeah, don't try to rush. Take your time. So far, all of you guys have been doing a really good job with the wiring. I've seen a really nice clean cut, like flimsy ones, so it's really good. And yeah, clean up after yourself. Have fun. Questions?